welcome back to the topic on phenols. We were studying the alcohols, phenols and ethers chapter. Alcohols topic is over. We will take some compounds, methyl and ethyl alcohol after the phenols. So phenols can be defined as hydroxy derivatives. In which OH group is directly attached to aromatic ring. Like phenol, like benzene or naphthalene, anthracene, etc. Aromatic system containing OH group directly attached to it. So the first example itself is phenol, is named as the phenol. This contains OH group directly attached to the benzene ring. Similarly, we have these cresols, in which the methyl group is another substituent attached to that phenol. So we have actually three isomeric compounds under this one. This is OH group and CS3 group in the ortho positions. So this is called as the orthocresol, or 2-methyl phenol, 2-methyl 1-hydroxybenzene. Like that we can name in different methods. So this is OH and CS3 in the meta position. 1 and 3 positions are named as the meta positions. Similarly, we have this para position, OH and CS3. This is paracresol. When we consider these dihydric phenols, so these are the compounds in which only one OH group is present. We have similarly dihydric phenols also, in which two OH groups are attached. So we have these examples: OH group in the ortho positions, OH, 1,2-dihydroxybenzene. This is also called as the catechol. Similarly, we have this OH and OH in the meta positions. This is called resorcinol. Similarly, OH and OH in the para position, this is called as the quinol, or hydrated phenol. We have this some examples for the trihydric phenols also. Trihydric phenols. Two important examples we have. One is having all the three OH groups in the 1, 2, 3 positions. 1, 2, 3 trihydroxybenzene. This is called pyrogelol. Similarly, we have this compound containing OH and OH in the 1, 3, 5 positions. This is called fluoroglucinol. So these are the various examples of the phenols in which we observe all the OH groups are attached to directly the benzene ring. Then we coming to the methods of preparations. There are so many methods available for the preparation of these phenols. Okay. The first method is starting from this benzene, sodium-benzene sulphonate. Sodium-benzene sulphonate. This sodium-benzene sulphonate is actually C6H5SO3Na. This is fused with NaOH. NaOH and fuse, we actually get followed by acidification with HCl. we get this C6H5OH phenol along with this Na2SO3, sodium sulfite. When sodium benzene sulphonate is fused with sodium hydroxide, it gives the sodium salt, which on acidification will give rise to the phenol. The second method is Cumin process. Cumin process. This is an industrial process, the most important process for the manufacture of the phenol. In this one, first we take this benzene. This is treated with propene, CH3, CH double bond CH2 in presence of H3PO4. Actually, this propene undergoes addition reaction with this one to give rise to, substitution reaction to give rise to C6H5CH3CH3. This is called as isopropyl benzene. Isopropyl benzene, that is also named as the cumene. This is first step. The second step is cumene is subjected to oxidation. CH3 twice we can write. This is subjected to oxidation. We get CH3OOH. Cumene hydroperoxide. We get cumene hydroperoxide. This cumene hydroperoxide is then subjected to acidification. COH CH3 twice. Cumene hydroperoxide. COH CH3 twice. COOH. Cumene hydroperoxide is then subjected to acidification. We get two products. One is this phenol, the other one is acetone, CH3COCH3. Phenol and acetone. Since these are the two important products, acetone is the byproduct during the manufacture of the phenol. Since no substance is wasted here, this is an efficient method for the manufacture of the phenol. That is called Cumin process. Cumene is actually an intermediate, that is isopropyl benzene, obtained during the substitution reaction of this propene with benzene. You can write the names benzene plus propene in presence of phosphoric acid. It gives rise to cumene, which on oxidation in air gives rise to cumene hydroperoxide, which on acidification will give rise to two products. One is phenol, the other one is acetone. So this is an industrial method for the manufacture of the phenol. The other methods for the preparation of the phenols, starting from this, from aniline. Aniline is a primary aromatic amine. So this first step consists of diazotization. When this aniline is treated with sodium nitrite, NaNO2 and HCl in the ice cold condition, that is 0 degrees Celsius, it gives rise to a product, that is C6H5 N double bond N Cl, along with the formation of NaCl and water. So this compound is named as the benzene diazonium chloride. This benzene diazonium chloride is obtained by the diazotization of primary aromatic amine. So anyhow, this type of property you will study in the nitrogen containing compound, that is aniline. This second step includes benzene diazonium chloride, that is C6H5N double bond NCl, is then treated with the water and then the solution is boiled. We get C6H5OH along with the liberation of nitrogen gas and HCl. Anyhow, we are using this dilute HCl and sodium nitrate solution. In this one we get benzene diazonium chloride as a solution. This solution itself is boiled to get the phenol with the liberation of nitrogen and HCl. This is phenol. This is the second step. The next method is actually called as the Dow's process. Dow's process. In this Dow's process, when we take this benzene C6H6, it is then oxidized in presence of vanadium pentoxide, V2O5. This will give rise to, this is chlorobenzene C6H5Cl. Then it is treated with sodium hydroxide. It is heated to about 300 to 400 degrees Celsius and a pressure of about 200 atmosphere pressure. This will give rise to C6H5OH along with this NaCl. OH group will be substituted in place of the chlorine atom. So that is called Dow's process. The next one is from sodium salicylate. Sodium salicylate. Sodium salicylate is actually OH, or we can consider salicylic acid itself. Anyhow, sodium salicylate is produced during the reaction from salicylic acid. This contains C6H4, OH and COOH in the ortho positions. That is 2-hydroxybenzoic acid is also named as the salicylic acid. This is then fused with sodium hydroxide in presence of calcium oxide. This mixture of sodium hydroxide and calcium oxide is actually named as the soda lime. When salicylic acid is fused with sodium hydroxide and calcium oxide mixture, that is soda lime, then it will undergo decarboxylation reaction to give rise to phenol along with this formation of the sodium carbonate. So COO group is eliminated to give rise to phenol only. Salicylic acid is available in the various plants, especially the Isle of Wintergreen plant. So that is extracted and fused with sodium hydroxide to get the phenol. The last one is from benzene. Benzene C6H6 is then subjected to oxidation in presence of vanadium pentoxide. Vanadium pentoxide is a very good oxidizing agent. It will oxidize this phenol, so benzene, to give rise to phenol, C6H5OH. So there are so many methods available for the preparation of this phenol. First two methods we have studied, from sodium salt of benzoic acid, sodium benzene sulphonate. Okay. The second one is starting from that is benzene plus propene, that is called as the Cumin process. Third method is by diazotization of primary aromatic amine, that is aniline. So aniline is subjected to diazotization in presence of sodium nitrate and HCl at ice cold condition. It gives rise to benzene diazonium chloride. This reaction is named as the diazotization process. This benzene diazonium chloride can be converted to various other products, but simply by warming the solution or heating the solution, we will get the phenol. The next step is Dow's process. Chlorobenzene is heated with sodium hydroxide under these conditions, at high temperature and pressure conditions, because chlorine atom is difficult to undergo substitution by other groups. This is actually a nucleophilic substitution type reaction. But it is difficult to remove the chlorine because it is an electron withdrawing group, electron donating group, positive inductive group. That's why under drastic conditions it will give rise to phenol. Similarly, from salicylic acid by decarboxylation. This process we call it as decarboxylation. For decarboxylation reaction, we use the mixture of sodium hydroxide and calcium oxide mixture. Solid sodium hydroxide, calcium oxide mixture. That is actually named as the soda lime. Soda lime. Remember this name. Fused mixture of solid NaOH and CaO, calcium oxide. That is named as the soda lime. So by heating with soda lime, we get this sodium salicylic acid undergoing decarboxylation to give rise to the phenol. The last one from benzene itself. Okay. By heating in presence of air and vanadium pentoxide, it gives rise to phenol. That is, hydrogen from this benzene is converted into the OH group along with this oxygen. So these are some methods available for the preparation of the phenol. Let us go for the properties of the phenol in the next video. Thank you.